Lesson 2.3 is on histograms. So the first part, this is page 85 in your textbook. The first part talks about Elaine. Basically she is a real estate agent, and she uses math on a daily basis to determine if individuals qualify to purchase a home, and then helps them calculate their mortgages and their taxes. And then does that in a comparative analysis, because when people are looking to buy a house or a condo or renting, they need all their options placed in front of them. They need to know that if they purchase this house, their mortgage is going to be this much, but if they purchase that house, what is going to be the difference in their mortgages? So it's shown as a graph that depicts the data of the number of apartments in different price ranges sold in Vancouver in September of 2009. So this is the price in thousands of dollars, which means this is 100,000, 200,000, 300,000, 400,000, 500,000, 600,000, 700,000. So if I look at this bar right here, this bar is between the 100 and 200, which actually means that this apartments are between $100,000 and $200,000 in price. And there was 100 units sold in that price range. Between $200,000 and $300,000, there was about 420 units sold. So, what trend does the histogram seem to indicate? Well, it kind of indicates that the average person spends between $300,000 and $400,000 on their apartments in Vancouver. And then it says, give as many explanations as you can for a trend that seems to be apparent from the diagram. Well, it seems to be apparent that they don't really sell apartments for less than $100,000. Not very many people buy apartments between $600,000 and $700,000, probably because it's very expensive. And the majority of people are buying units between $200,000 and $500,000. That's the trends that we see. This is an example of a histogram. It looks very similar to a bar graph, has a title, has a vertical axis that's labeled, has a horizontal axis that's labeled. The difference being where my bar graphs gave me this bar equals that. Just the one thing. In a histogram, it's a range. The other difference is the bars in a histogram get smooshed together, so they're connected. So a histogram looks similar to a bar graph. The main difference is that on the timeline or the amounts graphed are continuous rather than discrete, which is why they're shown placed together. Whereas in a bar graph, they are separated because the amounts for one are different from the next. In a histogram, the categories must be adjacent or next to each other, and they are usually the same size. Histograms can usefully depict ranges of information, and the bars are usually labeled with a lower and an upper boundary. For each bar, the data will include the lower boundary but not the upper boundary. So what that means is that in this right here, it includes $100,000 but not $200,000. Okay, so the 100 people that paid in this area here did not pay $200,000 for their unit. The people that paid $200,000 for their units are in this interval right here. So what I want you to do right now is press pause, and I want you to actually copy in the vocab terms, which if you can't see on the screen are on page 85 in your textbook. So what is a histogram, a lower and upper boundary? And you might also want to put in some differences. Things like the difference between a histogram and a bar graph is that on a histogram the timeline is continuous rather than discrete. Categories are adjacent and are the same size. And then I would also put in that the data includes the lower boundary but not the upper boundary. So that's the information that I would put in there. So again, press pause and then continue. So let's take a look at example 1, which is on page 87, or 86 and 87. French-speaking students from Manitoba and around the world attend Manitoba's Collège university colleges that offers most of the classes in French. Adele is a student who's completing a research project and interviewing people across Canada to determine the average number of hours of television they watch per week. So this is her interval. And if we look at this, at her results, this right here is saying this is the number of people that watch greater than or equal to 0 hours and less than 5. So between 0 and 5, but not including 5 hours. This is between 5 and 10, not including 10 hours. Between 10 and 15, not including 15, and so on. So then if I was to put this in a histogram, what I would need to do is I'd have my intervals from 0 to 35, going up by 5s each time, because that's the intervals I've included in my survey. And then I have my number of people, 2, 4, 6, 8, and 1,000 people. So question B, how many people watch between 10 and 15 hours of television a week? So between 10 and 15, 684. Question C, how many people watch less than 15 hours a week? Well, I have 684, 875, and 254, which is going to give me a total of 1,813 people. And then question D is how many people watch more than 15 hours a week? So that's 912, 345, 123, and 62. So together, that gives me a total of 1,442 people. What information is more obvious from the histogram than from the numerical data? Well, the average number of people watch anywhere from 5 to 10 or 15 to 20. It seems to be one of those two groups. Either you don't watch a lot or maybe you're on like the flip side. What information is not displayed in the histogram? The big thing that's not displayed in the histogram, well, first of all, anybody that watches more than 35 hours a week is not in the histogram. And the actual total amounts are not in there. And the last question, would this survey accurately represent the number of hours of television watched throughout the province? Discuss why or why not. Well, it's hard to say because all it tells us is that she interviewed people from across Canada. Well, how did she distribute her results? Did she phone the same number of people in each province? What about the province of Ontario that has far more people in it than perhaps the province of PEI? So we don't know exactly how reliable her results are, but if we assume that she followed all of the rules of taking a survey, making sure that the survey question was fair, making sure that she had an equal representation from all of the different provinces, and then even within the provinces, does she have a fair distribution of the type of people? Talking to low-income people and high-income people so that she gets a proper cross-section of people across Canada. So the next thing that I want to look at is I want to look at the mental math and estimation on page 88. It says, examine the histogram on the right. How many more employees earn $20,000 or more per year than those employees that earn less than $20,000 per year? So if I look at this histogram, 20,000 or more is this range right here. That's my 20,000 or more. So I have 5 people, 11 people, 2 people. So altogether, that gives me 18 people. Then I have my people that are less than 20,000 a year. 7 and 2 is 9. So how many more people earned more than 20,000 per year? The difference. 9 people, or 9 more people, earned more than $20,000 per year. On the following page is traffic engineering. So when traffic lights are installed, it's not installed by random. Studies have to be done in order to put a traffic light in place. Even in Fairview, there has been talk for a very long time about putting a traffic light where we have the four-way stop by A&W and Husky and Bargain Store. There was talk about putting a traffic light by Railside. And in order to be able to put those traffic lights into place, studies have to be done to see whether or not a traffic light is warranted. So they will put a machine up, they will put a counter, they might have somebody sitting in their vehicle, counting the vehicles, counting the flow of traffic to see whether or not that light is necessary. So that's what's happened in this. This talks about Ari is a traffic engineer, and what he's done is he's installed a counter to determine the number of vehicles that use a particular intersection during the afternoon rush period on a given day. His results are displayed on the histogram shown here. So I have one vehicle from 3 to 3:30. This shows, in hundreds, so 100. This one is about, I don't know, maybe 280 or 275 people from 3:30 to 4. 4 to 4:30, we have a little over 300 people. The peak time is between 4:30 and 5. I had over 600 vehicles using this intersection. So during what time period was there the most traffic? Well, I've just said that, between 4:30 and 5 p.m. So approximately how many vehicles use the intersection between 5:30 and 6? So that's between here. So how many vehicles do you get? I'm thinking about 450 maybe? Because remember, this is 400 and this is 500. That's what this right here is telling me. Approximately how many vehicles pass through the intersection between 3 and 7:30? So I'd have to go through and I'd have to start adding this all up. So let's use some estimation. This is 100, this is just about 300, and this is a little bit over. So let's make both of those 300. So I'm now at 700. Plus another 6, that's 1,300. Plus another 5 becomes 1,800. And then I've got these two here, which are about 450, so that would be 900 together. So I'm at 2,700. 3,000, about 3,200 vehicles. What other information other than the number of vehicles using the intersection might be useful for Ari if he's going to determine the traffic light sequencing and timing? So the timing is what determines how long the light stays green, and whether or not it should stay green longer if I'm going this way than if I'm going that way for traffic. Also could be, do I set it up on a timer or do I have a waiting system? Those of you that have traveled around Grande Prairie enough know that some of the intersections have a waiting system. They stay green going in the main flow of traffic until vehicles come from the secondary roads and basically trip a waits trigger underneath or hit a sensor that causes the light to change. The other thing I want to consider is how many vehicles are turning left, because left turning vehicles, maybe I need a left flashing lane so that those vehicles can turn safely. So those are all of the things that get to be considered, and those are some of the things that have to be put into the study. So again, putting a light is not just, oh, let's put a light here. There has to be a lot more thought put into it. So the questions that I want you to work on for this section start on page 90, and it's questions 1 to 7. If you are drawing histograms, make sure you're using grid paper so that your bars and everything are nicely matched so that you're drawing a proper histogram. I don't want to sketch, I want to see an actual histogram drawn. Okay, that is it for today's lesson.